Hello, I am Gareth Keohane, and welcome to my senior TED Talk on carbon nanotubes, aerogels, and fusion, along with their applications to space travel. This picture here is called Earthrise. It was taken from the moon of the Earth rising over the horizon like the sun. To get this beautiful picture here, we had to send our astronauts up in this giant metal machine. This is the Saturn V rocket, and it weighs about 3,000 tons. Of that 3,000 tons, about 30 tons of it are actually anything related to our crew and our mission. That is a little less than 1% of its entire mass. This thing is 99% dedicated just to get us to the moon, our closest neighbor in the solar system. This great inefficiency, however, has a few solutions available. Three of those solutions being carbon nanotubes, aerogels, and fusion. The question that I researched was, of these three technologies, which one is going to have the greatest effect on space travel in the near future? To answer this question, I first had to go into what are these three advancements. The first of these that I'll go over are carbon nanotubes. As you can see up there, carbon nanotubes are this kind of circular cylinder structure that is made up of individual carbon atoms. Unlike most advancements in material science, we didn't come across carbon nanotubes by mixing metals together to make something stronger. Instead, we observed this molecular structure being created after some testing. To make this incredible new substance that is very, very strong when built right, we use a method known as plasma arcing, which I could not, unfortunately, find a good picture of. However, what plasma arcing involves is you take a container of an inert gas, or a noble gas, whatever you want to call it, and you put in there two electrodes. These two electrodes are made of carbon, and you run an electrical current through them until a plasma arc is formed between the two of them, and it incinerates some of the carbon. That carbon eventually deposits again on our two electrodes in this shape that we know as a carbon nanotube. The second advancement in science that I looked at were aerogels. And essentially what aerogels are is creating a physical substance that is mostly empty space. Aerogels are in fact up to 99% empty space and weigh incredibly small amounts. As you can see here, you've got this stalk of oats, and these fibers are not even bending when they're supporting that piece of aerogel's weight. The great thing about aerogel is it is incredibly insulative. It doesn't allow heat or sound to travel through it because of its structure that you can see here. This is the gel structure. Gel is a hybrid liquid-solid substance that pretty much has these little bits of solid matter within a lattice of liquid. Now, normally, when you extract the liquid from a gel, it loses volume, and this structure that you see here collapses. To stop this from happening, we use a method called supercritical fluid extraction by injecting carbon dioxide at a supercritical point into our gel substance, and so when it evaporates, it doesn't collapse the structure, and the gel does not lose volume, and we get our aerogel. The final piece of technology that I went over was fusion. Fusion is essentially the process by which all stars burn and create energy. And it involves lighter elements, anything lighter than iron, being fused together into heavier elements, which releases a large amount of energy. For the purposes of mankind creating power, we tend to use hydrogen, especially the sub-elements of deuterium and tritium, deuterium being hydrogen with 1 extra neutron, and tritium being hydrogen with 2 extra neutrons. This mix can release a lot of energy. However, to create the fusion reaction with our hydrogen, we have to put it into a magnetic field that can contain it at 100 million degrees Celsius, an incredibly high temperature that is in fact hotter than the core of the sun, which is required because we don't have the same pressure that the sun provides for its own fusion reaction. Compounding issues with fusion include the rarity of tritium. To get tritium for our fusion reactions, we need to usually get it from nuclear reactors that are designed in a specific way because it's only naturally occurring in the atmosphere due to cosmic rays randomly bombarding hydrogen. So it is incredibly rare and only has a half-life of about 12 1/3 years. Fusion also runs into problems with actually containing a 100 million degrees Celsius plasma. It is so hot, it has so much energy within it, that our magnetic fields can't really contain it properly, and the world record for containment on a fusion reaction was set in France and is only 22 minutes long. So how do these different advancements apply to space travel? Well, carbon nanotubes see their dream application as structural components. Carbon nanotubes are about 70 times as strong as materials like stainless steel. They're with a massive ability to withstand force and impacts. However, carbon nanotubes have difficulty being scaled up to forms in which they can do that role. NASA's current project is working on creating a carbon nanotube reinforced material that is 50% stronger than what we currently use. Carbon nanotubes also, due to their ability to move energy around, can also be used to create electronics and sensors. Currently in aviation, carbon nanotubes are being created to build hyper-advanced sensors and hyper-durable sensors that, as one scientist noted, don't care about the environment they're in at all. Such sensors that can exist in nearly any environment can really help out with space travel because space is a really hostile environment with a lot of radiation in it, and sensors breaking is bad news for any sort of spaceship. With carbon nanotubes, we can make sensors that are less likely to break, and because they're less likely to break, we can bring fewer spare parts along with us, which require, more fuel to push into orbit because they weigh a lot. Aerogels see their impact in space travel with heat shielding. Heat shielding is incredibly important for spacecraft, along with being able to stop the sounds of liftoff from shaking the ship apart. Heat shielding allows us, when we're going at very high speeds through the atmosphere, to stop the heat created by friction from cooking our crew like baked potatoes. What's even better about aerogels is they're incredibly efficient insulators, meaning we need less volume of insulation for the same job, and since they're so light, since they're 99% air, they can really cut off a lot of weight. NASA is currently working on a re-entry vehicle project called the HIAD, H-I-A-D, that is using aerogels to protect its payload as it re-enters the atmosphere. This project saw successful testing in 2012 and marks the first of these technologies that I'm researching to actually be used in space travel. Finally, the great impact of fusion. Fusion is immensely powerful. There is a lot of energy going on there. It's about 4 times as powerful as any fission reaction that we can create, and 20 million times more powerful than any fossil fuels that we can use. Because it has this amazing energy density, it is much more useful to us than our current chemical fuels, and could allow rockets to be much more efficient because of their more powerful engines, so that we could get to further places. For comparison, fusion power is estimated to be about 300,000 times more powerful than the current chemical fuels that we're using in our rockets, which is a great advancement when we're trying to get to other places in the solar system. So, to answer my question, which of these three technologies will be the most effective and in the near future, I believe that carbon nanotubes takes the first spot. While it is not as far into its development as aerogels are, since it's not actually seeing any direct testing in any spacecraft, it is able to replace so many more components than aerogel does, and would really shave off a lot more weight than aerogel. In second place, I believe I would put aerogels. Aerogels are already being put into space travel. They're already in testing, and they're already in our corporate environment because you can buy hats with aerogel in it. And because they're so long into development, I really think that we're going to be seeing them get a lot of use in space travel in the near future. Finally, I put fusion last, not because it isn't powerful. I believe it far overshadows carbon nanotubes or aerogels, but it is so far behind the other two in development, I do not think it'll be an advancement that we'll see in the near future. We're still having trouble getting reactors to work, and the step from reactors to engines will be another one that will take a lot of time. So what does this mean for us as people, and what can enhanced space travel do for us? When I think about advanced space travel, I think about the new access to resources that will be available to us as a civilization. Earth is a limited environment with a group of people on it that really value a growing economy. Currently, our methods for resource extraction are really destructive. We have these massive open-faced pit mines and strip mining that does a lot of ecological damage. To fix this, we could use our enhanced rockets to go out and mine asteroids. These asteroids carry massive amounts of mineral wealth into them, and if we can get them into orbit of the Earth, and hopefully not, on a collision course, we can extract those resources and have enough material to really create a better world for everyone. Space travel and its advancement can also allow us to go to places like Mars. Most of Earth has been explored, and the drive for exploration has been crushed by the fact that there's no place to go to be the first person. Space travel can change that. Going to Mars can change that. We could have the new first step on a new world. We can have those people once again going out to be the first person to step foot on a place in all of history. We could really regain that drive. And I think that exploration could really give us a purpose and a reason to really come together and push forwards. These advancements like fusion could also really help us in the power sector. Currently, according to the BBC, we have about 40% of our total energy met by green energy. But getting that rest of the 60% of the way there could be really difficult. Fusion provides an answer to that. Fusion creates a lot of power, and because you're just fusing atoms together to create helium, it doesn't create any harmful gases like CO2 emissions, and it doesn't create any radiation like fission does. Fusion could really push us and make us get into a world with green energy and fewer worries about climate change, so that our resources can be pushed into making our lives better and advancing our society. Carbon nanotubes could also help us in the aviation industry. Better materials means better airplanes. And if our airplanes are better and can carry larger payloads, that could theoretically mean that moving things via air could get cheaper and more efficient, allowing the world to be more connected and allowing goods and services to move across the world at a quicker and cheaper pace. However, that is all the future. And today, is the day for action. In our current society, our scientific institutions are under attack. People don't believe in science as much as they used to. We have anti-vaxxers. We have so many people who just don't believe that science is worth it. But science can solve our problems, and we as a people need to work hard to foster a world and a society that values science, that will give science the funding and the resources that it needs to give us a better world. I know not everyone can become an aerospace engineer, but that's okay because we can still do our part by working hard to make sure that science is a respected industry that can work with us to create a better future. Thank you for listening.